So linear regression means finding the equation of the line of best fit in the form of y equals mx plus c. So remember back from coordinate geometry, the equations of lines of best fit, they will have a gradient and a y-intercept. So y equals mx plus c, remember m is our gradient and c is the y-intercept. And r is a different kind of thing. It's finding the Pearson's correlation coefficient. So it's a way of kind of actually being more quantitative and measuring whether or not the correlation is strong, weak or moderate. And also, of course, if it's positive or negative. So let's see how we do that. This will be largely using your TI and SPI, so make sure to have it nearby, have yours handy. So other than just looking at the graph, there are other ways of determining how strong the correlation may be. To do so, you use a thing called the Pearson's correlation coefficient. So the Pearson's correlation coefficient, R, this is a number known as R that can be found to determine more accurately whether there is a correlation or not. And whether it's a weak, moderate or strong correlation, and also on top of that, is it positive or negative? Remember, positive going upwards from left to right, negative going downwards from left to right. You can use the following table to make your conclusions, and this table is found in page 462 of your textbook. So by definition, all values of this Pearson's correlation coefficient lie between -1 and +1. So obviously a negative correlation here and a positive correlation here. If R is equal to +1, then we say the data is perfectly positively correlated. That means the data is a perfect straight line with a positive gradient. So basically the dots in your straight line form a perfect straight line. They're not so scattered. That would be if R is +1. That's the highest value you can possibly have for a correlation coefficient. If R is between 0 and 1, then generally we just say the data is positively correlated. If the data is something close to 0, like 0.1, then you could say that's a weak positive correlation. If it was something like, for example, 0.56, then that's a kind of a moderate positive correlation, for example. And if it's something like 0.9, then that's a strong positive correlation. If it's 1.0, then it's a perfect positive correlation. If your R is close to 0, then the data is no correlation. Remember, that's when there's no positive or negative trend. The data is just randomly scattered. So if R is really close to 0, then the data is no correlation. If the R value is between -1 and 0, in general we say it's negatively correlated. So something like -0.1 could be weak negative correlation. Something like -0.6 could be moderate negative correlation, and something like -0.9, for example, could be a strong negative correlation. And again, if R is exactly -1, then the data is perfectly negatively correlated, meaning the data points form pretty much a straight line with a negative gradient. Similarly, how R is +1, it's a perfect positive line. If R is -1, it's a perfect negative line. So data, when we collect data, it tends not to be perfect. You tend not to get an R equals +1 or a -1, but something in between. Okay, so looking at this one, state the correlation associated with the following R values. So, sorry, I'll need to type this. So 0.53. What kind of correlation do you think that might be? Let's write our little answers down here. We don't need to size that big. So R is 0.53. So it's definitely positive. You might say moderate, weak to moderate. Moderate positive. Correlation. Was it like something like, basically it's a positive correlation. Something like 0.02. What might that be? Sorry, -0.02. That's really, really close to 0. So you could pretty much say that's no correlation, as it's so close to 0. -0.02. Something like -0.9, that's pretty strong, and it's a negative. So I'd say a strong negative correlation for that, because it's pretty close to, very, very close to being -1. Something like +1, that's what we call a perfect positive. So basically like a straight line. Perfect positive correlation. Very unusual to get that result. Something like 0 is exactly no correlation. So no doubt about that, that's no correlation. For those particular ones. Okay, let's move on to the next one. So linear regression on the TI Inspire. So I'm going to teach you how to do a linear regression on the TI Inspire. You're going to also how to make a scatter plot on your TI Inspire, how to plot the line of best fit on your scatter plot. And remember, linear regression is what is the exact equation of the line of best fit. And also on top of that, how to find the Pearson's correlation coefficient. So if you are asked to perform a linear regression, this might be a new kind of word for you. So you might be asked to perform a linear regression in an exam. You're just being asked to use your TI Inspire to come up with the equation for the line of best fit in the form of y equals mx plus c, where, remember, m is the gradient. So m is the gradient and c is the y-intercept. Remember, m is the gradient, c is the y-intercept. That's what you're being asked to do. So watch the second video on Firefly. So actually I'm going to just leave it on this video. So continue to watch this video on Firefly for this topic and see how you use your TI Inspire to perform a linear regression. So keep watching the same video because I'm just going to put it on one video now. Watch the video on Firefly, the current one you're watching, to perform a linear regression and find the value of the Pearson's correlation coefficient for the following example. So I'll get you can write your own TI Inspire instructions, and I'll just do a little demonstration right here for you. So we need my Inspire. So get your Inspire out. So the first thing we need to do is we need to enter this data into a spreadsheet. So we're going to enter this data into a spreadsheet. So my Inspire keeps disappearing. Here it is. Okay, so see along here, if you're not there, just go to to the home button. See the spreadsheets down here. So if you're not down there, go down, select a spreadsheet here. So enter. You can name your spreadsheet. So see, we've got time in days and cost. Let's make this a bit bigger again. Time in days and cost. So to name it, we should go up here. So go time. You can just type it in if you like. T-I-M-E. That's a great thing about this is you've got a whole keypad down here. We've got time there, and we have what's the next one again? Cost, wasn't it? Cost. So notice we're in the top. We're not in the second one down. We're in the top. So cost. C. Is it O? I is bad. ST. Time and cost. Start to enter in your data. The data should be entered down here into the white section. So 0, 1, 2, 3, 4. That's easy. Make sure to enter it in correctly. 0, 1, 2, 3, 4. These are kind of touchy calculators, so really make sure that you've entered in the right data. Go back up and check. 4, 3, 2, 1, 0. I've got them all. Yay. Next one, 0, 2.2, 0, enter. 2.2, enter. 3.96, 0.96, enter. 6.24, 0.24, enter. It's 8.05. 5, enter. You should always check because it's so easy to type in the wrong numbers and then the whole thing's messed up. So feel free to pause and write down the instructions for what you did there. So remember, you went to home and you opened a spreadsheet, you named the spreadsheet, and then you typed in the numbers. Now I'm going to show you, first of all, how to do a quick scatter plot and get the linear regression. Actually, no, I should show you how to find Pearsons as well at the same time. So I'll teach you how to do all of that at once, and then I'll show you a shortcut if you just needed the linear regression. So to do it all at once, what we need to do is we need to go to, and so now what we want to do is, because you're in the spreadsheet, you want to do a statistical calculation. So go to menu, and what do you think you would go to do a statistical calculation? That's right, you would go down to statistics. So from here you arrow down to statistics, you will select stat calculations, and we are doing a linear regression. So we're doing a linear regression. See, there's two versions. There's a linear mx plus b, a plus bx. We're used to mx plus c, so let's select mx plus b. Very similar. We need to tell them what our x list is. So remember, our x list, we'd named it something nice. Oops, sorry, it's a bit difficult on here. We'd named it something nice, so select the arrow, and our x list was time. Our y list, what did we name it? We named it cost. So giving it something kind of like time and cost just helps you to keep track of what's going on, because remember, time was our x list, our independent variable, our y list was time. This is all good because it wants to save the equations to the next section, so just go OK. Go OK, or you can just go enter, and you'll see some extra things have popped up. So over here we have our time and cost over here, and here we have our regression equation. So notice our regression equation is mx plus b instead of mx plus c, and our m is our gradient, so our gradient is 2.014. Our y-intercept is 0.062. And notice that we should write it out to 3 sig figs. So you can sort of hover around here, and I think it gives it to you to more. Does it give it to you better there? Okay, that might be more specific if you kind of hang around there. Maybe it is exactly 0.062. That's probably why. Oh dear, what have I just done? Okay, just let me pause this for a second. Okay, I just went back and popped it back in again. Right, cool. So we can write, you write your instructions for how you did that. So what we've got here is we have a number of things. We have y equals mx plus c. So to write our regression equation, we need to substitute in the m value and the c value. So the gradient is 2.014 or 2.01 if you want to do 3 sig figs. The y-intercept is 0.062, which we're assuming is rounded. I mean unrounded, like a whole answer. So what we have here is, and sort of notice it kind of does give it to you kind of less rounded. So nothing's popping up here, so perhaps it is just 0.062 exactly. So R value is our Pearson's correlation coefficient. It's 0.999. That's a pretty strong correlation. Okay, so you can pause and write your instructions for how you did this in your own words, because it's for you to look back and reflect on. So the equation of the line of best fit, as I said, needs to come from here, y equals mx plus c. So I'll just need to type it because I'm typing at the moment. Okay, so it's y equals mx plus c. So you could say it's y equals, what's our gradient? It's 2.014. And it's an exact value, so you could put 2.01 to 3 sig figs. Don't forget your x plus 0.062. Where are they coming from again, in case you missed that? It's coming from here, because you remember y equals mx plus c. Our m is 2.014 or 2.01. Our y-intercept is positive 0.062. So if that helps, let's pop them in different colour, so when you look back you might sort of look back and see that these numbers came from the calculator. There you go. So that's our equation of the line of best fit. That's the result of your linear regression analysis. So they might have said perform a linear regression. It means just find the equation of the line of best fit. So if they used C for cost and T for time, you would put in a C for cost and a T for time. But those variables weren't defined in this question, so we can leave it as Y and X for now. So that's the equation of the line of best fit. Let me circle that just to point out that that's your answer. This thing here is the gradient. Feel free to write that as well. This thing here is your y-intercept. You might want to write that in as extra notes. I'm finding it difficult to do because I'm on the laptop. I'm not on the smartboard right now. The Pearson's correlation coefficient, you can just get from your calculator. So it's R equals, it's lowercase r, that's important to use that. Our R value, if you can't see it, just scroll down. Don't use R squared, use R. So 3 sig figs, that's 0.999. So R equals 0.999. That's your answer, so let's circle it. So you can look back and realize this is what they were looking for. Out of interest, what kind of correlation is that? Just as something extra we can add in. That's a strong, very strong, positive correlation. It's super close to the value 1. Okay, awesome. So that one's been done for us. Let me also show you how you can quickly draw the graph. Let's get our TI Inspire back up. Some people just like to see how you would plot this on a graph. So to do that, notice you've got your data plotted. If you scroll across, see you've got your time, you've got your cost. I'll scroll down, there it all is. So you can go to New Doc. This is how you could do a quick plot of your scatter graph. Remember, like, Very rarely you're going to be asked to do this, probably never on your calculator, but it's just interesting to, so you can, if you had to draw the scatter graph by hand, you can have a quick check to see does it look okay. So you can go Control, New Page. So Control Doc is a new page. Add Data and Statistics. Enter. There you go. See down the bottom it says click to add variables. So we need to tell them that our time is our X and our cost is our Y. So use your little kind of mouse. Notice you can kind of scroll down the central mouse pad, scroll down to here. You've got a choice. You'll have different kind of things. Time is for this one. Then scroll across so you're over here. List of different options come up. Cost is the one we have for this one. So your scatter graph hopefully looks something like this. And you can quickly just double check, like a quick way, if you didn't need the Pearson's correlation coefficient, you just needed the equation of the line of best fit, this could be a quick way to do it. So you can go Menu, and it's Analyze. Menu Analyze, Regression, and is it quadratic? Is it a cubic they want? No, they want a linear regression. So select the first one, y equals mx plus c, because that's all mx plus b, that's the one we're used to. There you go, here's your awesome little equation, you can move it around. So same thing, y equals 2.014x plus 0.062. So that's okay, I just happened to round this one to 3 sig figs. But if the answer is exactly 2.014, it would have been fine to leave it as 2.014. See time and cost. So that's a quick way. If you didn't need this Pearson's, you could have just quickly put in your spreadsheet and then just gone straight to doing this. That's a quick way to do it. So maybe the next ones I'll show you doing it that way, and then we can do the Pearson's afterwards as an afterthought. So watch the second video. Now it's still just watch the video on Firefly for this topic to see how to use your TI Inspired to perform a linear regression and find the Pearson's correlation coefficient. So we're going to try just doing the shortcut where you go straight to the linear regression equation. So the y equals mx plus c. We've got different data this time, so we'll need to start a whole new one. So control off. What am I doing? I just want to go back to my home page. So we want a new one. Got a new sheet open. What's our data all about this time? It's about time and height. So notice what's going to happen. You might kind of feel free to erase, get rid of any previous sheets you've got, but I'll just also show you what happens if you, because we already have a time thing worked out from the past. So see, it tries to plug in the old time. That's not a big deal. What you can do is, if you don't need the old time data, just go and start a new one. So just go 1, 3, 7. See, I'm just putting the new time data over the old time data. No problem. 4, 11. Check, you might have some down below. If you did have some down below, just delete them if you like. So no harm in doing that. Time, if you could have just, if you wanted to keep your old time data, you could have made a new one and just called it time brackets weeks. So you could have called it time bracket W for weeks instead. And the next thing we need here is height. So height, H-E-I-G-T, where's my H? H-E-I-G-H-T, where's my G, G-H-T? I'm getting used to this keyboard. Yay. Okay, height. So remember we put them in here, and then the data goes further down here. So then 1 week corresponds to 3. No, it doesn't, corresponds to 9. Oops. So yeah, good to double check everything's going well. Don't know what I did there. 9, 26. So 2 weeks, 3 weeks goes with 96. 7 weeks goes with 101 centimeters, height in centimeters. 4 weeks goes with 40 centimeters. I could be talking about all sorts of things, heights of plants, trees, anything. Could be an animal. It's not quite been defined. So 1, 3, 7, 4, 11, that's good to check, and then check 9, 26, 101, 40, 126, wicked. So what we want to do is, I'm going to show you that shortcut, again, like how to get straight to the regression equation, but unfortunately it doesn't give you the Pearson, so if the question wants both, unfortunately you'd need to do it the other long way, but I'm just going to show you the shortcut, because quite often you might find in the topic assignment they just maybe only want to know the equation of the regression line. So this is a shortcut for doing it. Enter in your data and then go Control, New Page, Control, New Page, add data and statistics, and again it wants you to tell us what's the X data. The X data is time, time. There it is. If you had time in weeks, you would have to select time in weeks. Height is this data, so notice it's not cost anymore. So if you drew a scatter graph, hopefully it looks like that. And to do your regression equation, remember you go to Menu, Analyze, Regression. All sorts of different regressions you can get, and in later units you'll learn about doing quadratic regressions, cubic, logarithmic, exponentials, but for now we're just doing linear regressions, like straight line regressions. There's our lovely little line of best fit. So we should probably write it out to 3 sig figs, so that would be y equals 12.7x plus 5.42. So our gradient is 12.7, it's a positive gradient, makes sense, and our y-intercept is at, oh, that's -5. Actually, I just noticed because I realized, see from the scatter graph that's going into the negatives. So -5.42. Okay, let's start to write that. Equation is y equals, what was it again? It was 12.7, 12.7x, and it's plus negative. So just say minus, because plus negative means minus. Our y-intercept is -5.42. There's your gradient. You might want to make a little note of that. Say that 12.7 is your gradient, and this thing in blue is your y-intercept, -5.42. So that's done. What's painful though is if you need to find the Pearson's correlation coefficient, you need to go back and do it the long way. So as I said, I showed you this short method just in case the question only ever wanted this. But if you happen to want your Pearson's correlation coefficient ever in your math career, it's good to be aware of this other method. So we need to go back to our our spreadsheet. So see, to go back to your spreadsheet, so you've got 1.4, you've got the graph here, just go back to 1.3. There's your spreadsheet. Does make sense, doesn't it? That's your data. And remember, how did we do this beforehand? We went to Menu, we went to Statistics, we went to Stat Calculations, and we went to Linear Regression MX plus B. So we've got to tell them that our time is our x data. It's the independent variable, remember? And now it's not cost this time, it's height. Okay? See, this is the other way it came up. So see, the gradient's 12.7, the y-intercept is -5.42. The benefit of this method is it tells us what the R is. Our R is 0.978. It's a 3 sig figs. 0.978. R equals 0.978. Not very interesting, is it? Because again, that's another strong positive, not negative, positive correlation. And let's just circle that. Here we go. Okay, that's done. Okay, now let's do another example. Feel free to pause and just try this one yourself and just check if you get the same answers as me. So I've tried to put one that's slightly different. You might not get a positive correlation this time, you might get a negative one, just to show you that it's possible. Rightio. Okay, so we need to do a new one, so let's go to On, and let's select a new spreadsheet. Great. So what's our data this time? We've got temperature and coffee sold. So let's maybe pop that in here. Temperature again, like you'll notice that if you want to keep your old temp data, just call this something slightly different, like call it temperature 2. But if you can also erase old kind of data as well, kind of get rid of old spreadsheets. So temp C, oh, I didn't have a temp, so don't worry, it's gone. If it does try to bring up old temp data, it's fine, you can just type over it, or you can erase the old temp data and just start a whole new kind of spreadsheet. 27, 12, 20, and 7, and 21. Let's see, did I do any boo-boos here? So I've got 21, 7, 20, 12, and 27. Brilliant. The next thing is number of coffee sold. So it's hard to kind of write that in. So I'm going to write just NO space coffee. NO number space COF. Let's put in coffee, why not? Number of coffees. Cannot change invalid input. Okay, what did I do wrong there? Maybe it's because of the space. So just put coffee then if you prefer. Coffee, COFFEE. Coffee. It's pretty obvious when you go through it what it is. 5, 35, 9, 59, 9. So just double check everything. 21 and 9, yep. 7 and 59, 20 and 9, 12 and 35, and 27 and 5. So our independent variable is the temperature, and the dependent variable is the coffee, because we're assuming number of coffees sold is affected by the temperature outside. Do you want to see the shortcut version? The shortcut version, which will get you straight to the equation of the line of best fit, in case that's all you were required to find. So remember, go to Control, New Page, Add Data and Statistics. We've got to define what this variable is. This variable, it's not coffee. The variable is temperature. And this variable you need to mouse across, and it's coffee. So it's a negative correlation this time, isn't it? So that's pretty cool. And then what we can do is we can go Menu, Analyze, Regression. It's a linear regression they want us to do, not a quadratic or a cubic or anything like that. So mx plus b. Lovely. Here's our equation of our line of best fit. So because it's a negative correlation, we've got a negative gradient. So that makes sense, doesn't it? Y equals negative 0.80x plus 72.2. So let's get ready to type this in. Y equals, and it was negative, what was it again? It was negative, sorry, I've got to get my calculator up. Negative 2.80x, 2.80x. Doesn't want to type unless I'm here. 2.80x. And what was the rest of it? 2.80x plus 72.2. Plus 72.2. Have a look, does that make sense as well? Do we have a y-intercept around 72 point something? Yeah, we probably will, because see, like, 10, 8, 6, going further down to 0, it's probably going to hit at 72.2, and it has a negative gradient, so that's great. So again, for your own notes, you might want to write in that this is the y-intercept. So y-intercept is 72.2, and the gradient is negative 2.80. Let's circle that. So what does the y-intercept mean in this situation? So what it means is how many coffees sold approximately would we get if it was 0 degrees Celsius. So if it was 0 degrees Celsius, we'd get probably approximately, according to this trend, 72.2 coffees sold. The Pearson's correlation coefficient, as I said, that's the downside of this shortcut method, is it doesn't also give you the Pearson's correlation coefficient. You might find plenty of exam questions don't necessarily want the Pearson's correlation coefficient, but if they do, then this is what you need to do. Just go back to, go back to 1.4. There's your data, beautifully set up. Just go Menu, and it's Statistics, this topic, and we want, it's a stat calculation, and we want linear regression, mx plus b. So we've just got to tell them, good, thanks. We've got to tell them that it's the temperature here, and we've got to tell them that it's the number of coffees here. Okay, enter. Here it is. See, it's just confirming your data, your results, which is quite handy, -2. So in case you missed a negative, maybe it's good to just do this anyway and just see if you get the same numbers, because maybe the numbers look clearer. And the correlation coefficient is negative 0.954 to 3 sig figs. So negative 0.954. Remember, we're not looking at r squared. R squared is the coefficient of determination. It's a different thing. Pearson's correlation coefficient is r equals negative 0.954. R equals negative 0.954. Fantastico. What kind of correlation is that? That is a strong negative correlation. So it's pretty boring. They've all come up with strong correlation so far. Strong, sorry about that. But what's interesting about this one, it's a negative correlation. You weren't asked to comment on it, I just thought I'd put it in there. Strong negative correlation, but the actual answer they were asking for was this. So thank you very much for your patience, and hopefully that has revealed to you how to use the TI Inspired to do a linear regression to find the line of best fit, also to how to do a quick sketch of your scatter graph to check your own answer on paper, and how to find the Pearson's correlation coefficient. Thank you all.